right, 11.1 looks at some geometry. So we've looked at parabolas before, but this section is interested more in the geometry of parabolas. Specifically, parabolas with the vertex at the origin. So unshifted parabolas. So what is the definition of a parabola geometrically? So a parabola is formed by points that are an equal distance from a fixed point P called the focus. So that's this guy. And a fixed line L called the directrix. So that's this guy. So in other words, if we were going to actually trace out points on this parabola, they would all be points that are, so if I'm at the, say I'm at the vertex, so the distance to the focus point would be equal to the distance to the directrix. So that gives me that origin point. Look, if I'm at a point here, let's do a different color. The distance from this point on the parabola to the focus would have to be the same as the distance to the directrix here. So I can keep on going. This distance, the distance from the point on the parabola to the focus point, would have to be the same as the distance to the directrix. So if you keep on going with that scheme, ultimately you're going to get all the points on that parabola. So let's see if I can come up with the geometric equation of this parabola then. I'm going to use the green lines there for reference. So let's see, let me say this point, call that the point XY. So what do I know? Well, I know this distance, the distance from this point to the directrix. Let's see what that distance is first. So let's see, what is that distance? How could I write that? Well, let's see, this portion is P. What is this portion? Well, I guess that portion is just Y, isn't it? Because that's how I get to that point on the graph, right? I go up a distance of Y, so that height would be Y. So the whole red length here would be Y plus P. So what do I know? Well, I know that that Y plus P has to be equal to this distance, the green distance here. So what the heck is that one? So for that one, I need the Pythagorean theorem. So let me clean this up a little bit. This one we already found. Okay, so looking here, let's see. Well, this distance is X, right? Because if you look at the point, how do you get to that point? You go right by X. Okay, what about this distance? This height? Well, what would that be? Well, starting from here and going all the way up, that's a distance of Y. This is a distance of P. So wouldn't this be Y minus P? So what I have to do is I have to use the Pythagorean theorem. Because what I'm interested in at this step is finding this distance. So what would be true? Well, the base squared plus the height squared would be equal to the hypotenuse squared. So what did I do there? I'm using the Pythagorean theorem for this triangle. So x squared plus y minus p squared is equal to the distance of that hypotenuse squared. Okay, so the length of that hypotenuse would be the square root of x squared plus y minus p quantity squared. Okay, but now I know that distance, so this one, is equal to that distance, which we found to be y plus p. So actually that gives me my equation. Okay, and then I just have to solve that equation, or simplify that equation, I guess I should say. Let me move this for the moment. So let me see, I think I would square both sides here. Okay, so be careful there, you have to do a FOIL. So y squared plus 2py plus y squared. And then I have to do a FOIL. Y squared minus 2py plus p squared. I think I have a mistake. Let's double check. So I'm always double checking. Let's see. So I'm squaring y plus p. Let's make sure I did that right. I think that's where I made a mistake. It should look like this. Let me look at the other side. Okay, x squared. Then I'd have y squared. I have minus 2py's plus a p squared. I think that looks okay now. Now I should get some cancellations. Okay, y squareds will cancel. P squareds will cancel. Oh, so that turns out nice. So let's see. What do I have left? Then I have an x squared equals a 4py. What am I doing? Okay, so there's the equation for a vertical parabola with focus at 0p. So the equation's easy. Getting it's a little more interesting. So that's a vertical parabola. So it's the one like this, right? Now you might be able to guess y squared equals 4px is the equation for a horizontal parabola. So the derivation would be very similar. You just have to rotate the parabola. So I won't do the derivation again. Okay, so like that would be if the parabola looks like this. And it would have a focus point here at p0 inside the parabola. So those are the two equations. And both of these have a vertex at the origin. So really the two equations that I need are these two. But the derivation is kind of interesting. It's fun geometry. And so how would you actually apply some of this? Find the focus, directrix, and focal diameter. So we've worked with this parabola a lot before. Y equals x squared. But now we're going to look at it from a geometric perspective. Okay, so first of all, well, I know y equals x squared is a vertical parabola, yeah? So I know I'm dealing with this setup. Okay, so I know I'm comparing with x squared equals 4py. So my equation is just x squared equals y. So what is the coefficient? The coefficient is just 1. So I would conclude that 4 times p is equal to 1. So p is equal to 1/4. In other words, when I go to graph this parabola, its focus point is at 0, 1/4. Okay, that was one of the questions that was asked. It said find the focus. What about the directrix? Well, remember the directrix is an equal distance away from the vertex, so it's going to be down here, right? See if I can do a better job drawing that. So that equation of that line would be y equals -1/4. And the focal diameter. So let me draw the graph. So let's see here. Well, let me plug in a point. So let's see here. So if I'm looking at the equation, let me see if I can just add a couple points. So y equals x squared. So what if I plug a 1 in there? If I plug a 1 in there, I get a 1 out, right? I know the parabola has a point at 1, 1. So let's see, 1/4, 2/4, 3/4, 4/4. Call that 1. Call that 1. So here's another point. And then I have another point at -1, 1. So let me get one more point. So maybe what happens if I plug in a 1/2? That's a 1/4. Okay, so if I come here to a 1/2, I go up to a 1/4. There's a point on the parabola. -1/2, a 1/4. Okay, so there's that familiar shape. Let's see if I can answer the last question. So find the focal diameter. So that means if I go right through the focus here, what is the length of that diameter? Well, that's pretty easy, right? I have a 1/2 plus another 1/2. So that focal diameter, that length there would be a total of 1. So we'd say the focal diameter is 1. So there are all the answers, and we drew the graph as well. Scroll down to the next one. So the next one, I can tell that guy, that's a horizontal parabola, because I noticed that it's the y that's being squared. So remember, I'm looking at these two equations up here, these two. So I know if it's a y squared, I have a horizontal parabola. So that means I'm thinking about, okay, this is my equation for a horizontal parabola. So let's see, what happens if I solve this for the quadratic term? Okay, so now I'm comparing. I keep making small mistakes. Copied this equation down wrong. So let me go run through it one more time. So when I first see this equation, I see that I'm dealing with a y squared. So I know if I'm dealing with a y squared, I'm dealing with a horizontal parabola. So that equation would be y squared equals 4px. So what I did then is I solved my equation for y squared. Looks like I did that part right. Then I'm comparing the two. So I know the coefficients need to be equal. In other words, I know 4p has to be equal to -3. P has to be -3/4. So let me see if I can do a sketch. So if P is negative, this guy's going to open to the left. The focus is always inside the parabola. Okay, so the focus is at -3/4. So should we do 1/4, 2/4, 3/4? Here's the focus point. So we'll use a different color. -3/4, 0. Okay. So then the directrix is going to be an equal distance away from the point here at the origin. But this time that directrix is going to be a vertical line. So this is going to be x equals 3/4. So then, I already know what this thing basically looks like. But, so let's see, I guess we can start answering the questions. The focus, -3/4, 0. The directrix, x equals 3/4. But then what about the focal diameter? So how would I get that? Well, that's saying on the parabola, if I'm at the focus, what is that diameter across the parabola? So I guess, what if I take the parabola and I plug in -3/4? Let's see what that gives me. So like, go back up, let's see, I can even write something. Plug in -3/4 for x. So I go back up to, you could use either equation. This one or this one. Let me use that y squared equals -3x. Okay, so if y squared equals 9/4, then y equals ±3/2. So you can see here that that means this point would be at -3/4, 3/2. So my scale is actually not that great because this parabola is going to be pretty wide then. Let me see if I've even made it big enough. Probably not. The scale. If I was to do this in fourths, I'd have 1/4, 2/4, 3/4, 4/4 would be 1. So maybe I can squeeze it in. I kind of want to, so we can see the scale. Let me move this over. So if I move this down a little bit, bet you we can fit it in here. To extend that a little bit. So let's see. So I'm trying to plot, so here's 1. This is in quarters, so this would be 1.5, which is 3/2, right? And this would be 2. So when I go to plot the point, let's see, what was the point? The x was -3/4, the y was positive or -3/2. So that means I'd go up to 3/2, that'd be here. -3/4, 3/2. And then I'd have the same thing on the negative side here. I have enough room. There's -1, -1.5. Would be -2. So the point, -3/4, -2. No. -3/4, -3/2. Okay, so then that's a wide parabola, since we actually did a decent job showing the scale. So when I'm actually looking for that focal diameter, I'm looking for this distance. So I've got a distance of 3/2 plus another distance of 3/2. So 1.5 plus 1.5 is 3. So that focal diameter is actually 3. That's a cool one. harder, huh? Find the equation of the parabola with vertex 0, 0 and focus 5, 0. Okay, so I'm not doing a fancy sketch. I'm just saying, okay, so if the focus point is here, I know this is a horizontal parabola. So a horizontal parabola is a y squared equals 4px. Remember, the focus point is p0. So actually, I know p is 5. This problem's really easy. So the equation is just y squared equals 20x. Find the equation of the parabola with vertex 0, 0 and directrix y equals 1/7. Again, a rough sketch. So the directrix is horizontal. So that's here. Okay, so that means the parabola opens down. Remember, that opens away from its directrix because its focus point is going to be here. Okay, so if this line is at y equals 1/7, that focus point has to be at negative 1/7. So that means that the p has to be negative 1/7. So that focus is opposite of that directrix. So then I know this is a vertical parabola, so it's an x squared. And I know the p. Negative 4/7, and there's my equation. And that's it. It's a fun section.